Today we're going to look at average rate of change problems and some applications. So we've got some brief notes to do, and then we're going to get to the we do section. So an average rate of change is basically our slope on an interval. So we're given two ways to write it, where we're looking at the interval a to b. So it's the difference in our y's over the difference in our x's, or in function notation, f of b minus f of a over b minus a. So this is also the slope of the tangent line. And the tangent line is something we're going to talk about, of the secant line. The secant line is what we're going to talk about today. Tomorrow we're going to talk about the tangent line, which is going to be the slope at a point, or the instantaneous rate of change. So right now we're looking at the average rate of change on the interval 1/2 to 3/2 of x cubed minus 2x. So if we're imagining 1/2 to 3/2, we're looking at the slope, between those points. Because it intersects our curve twice like that, that's called the secant line. And we're looking for the average rate of change, or the slope. So we're looking for f of 3/2 minus f of 1/2 divided by 3/2 minus 1/2. Okay, so let's go ahead and calculate that f of 3/2 and f of 1/2. So we got 27/8 minus 3, least common denominator of 8. So we got 27/8 minus, sorry about that, 24/8, which equals 3/8. Then I've got 1/2 cubed minus 2 times 1/2, which is going to be 1/8 minus 1, multiplied by 8 over 8. Going to get negative 7/8. So up here I'm going to have 3/8 minus 7/8. Minus negative 7/8 divided by 3/2 minus 1/2, which is 1. So minus the negative becomes a positive. So I've got 10/8, right? And 2 goes into both. So I've got 5/4 as my average rate of change. One half, 3/2. So that's what this is, aka the slope of our secant line. So we got a couple more examples to look at. This one's going to be an application problem. So we're looking at the function h of k, which is equal to 3k squared minus k, which represents how long it takes Mr. Brust to clean his house, where h is measured in hours and k is measured in the number of kids Mr. Brust has. What is the average rate it takes to clean his house when he has between 1 and 4 kids? So now we're looking at h of 4 minus h of 1 over 4 minus 1. That's the average rate of change, remember, or the slope of our secant line. All right, so we've got 3 times 4 squared minus 4 minus 3 times 1 squared minus 1 over 4 minus 1. 4 squared is 16 times 3 is 48 minus 4 is 44. 3 minus 1 is 2. 4 minus 1 is 3. 42 divided by 3 is 14. So that's 14 hours per kid. All right, now we've got it in terms of a variable, so we're looking at the interval x plus h, and this is going to become important when we start looking at the limit definition of a derivative. So tomorrow. So our average rate of change on the interval is now going to be this guy. So this is going to get kind of long when we write it out, so just bear with me. And since it's minus the f of x, we're going to flip the sign on each thing. X plus h minus x is just going to be h. Then we have to FOIL. So I'm going to have x squared plus 2xh plus h squared. Distribute minus 4x minus h, 4h, yikes. If I can write, yeah. Okay, plus 1 minus x squared plus 4x minus 1. All right, now we get to cancel a bunch of stuff out. So we've got an x squared and an x squared, those get out of town. Negative 4x, positive 4x, those guys leave. Positive 1, negative 1. So if we write this again, got h squared plus 2xh minus 4h divided by h. You'll notice that we have a common factor here of h. So I can factor that out. And then I've got h and h, those cancel. So my answer is h plus 2x minus 4. And that's the average rate of change on that interval. All right, and then we've got one more we're going to be looking at today. So I'm going to make every second line one unit. So 4 minus x squared is going to have us starting up here when we've got an x of 0. When you have x of 1, you're going to be at 3. You have x of 2, you're going to be at 0. So our function is a parabola that looks like that. And we're looking at the interval 1 to 2. So from 1 to 2, it's from here to here. So we're looking at the slope of that secant line. So remember, the green is the secant line. The slope of the secant line is the average rate of change. So I've got g of 2 minus g of 1 divided by 2 minus 1. So that's going to be 4 minus 2 squared minus 4 minus 1 squared divided by 2 minus 1. 4 minus 2 squared is 0 minus 4 minus 1 squared, negative 3, divided by 1. we've got -3 as our slope of the secant line, or the average rate of change of the function on the interval. Then we've got two definitions for the slope of the secant line, so go ahead and write those down.